Hello, trig honors students. God bless you. And here is the review practice video I mentioned that I would do for you. I trust you'll find it very, very useful. I'm going to be taking a look at the practice quiz I gave you. Went over it in class with some of you already, but look with me as we take a look at the first few here. It says here, find the reference angle for each of the following angle measures. So here we've got 240 degrees. The reference angle, remember, is going to be in reference to what? Always either the positive x-axis or the negative x-axis. So if we take a look at what we've got here, 240, we start right here and we go around here. This would be 180, and 180 plus what would give us 240? 180 plus 60, that would probably drop us about here. And so our reference angle in reference to the x-axis would look something like this. This little angle right here. I want to give it a second arc to emphasize it. So that's going to be it here. It's going to be 180 here, and then another 60 here. So that would be 60 degrees. All right. How about the next one? Let's see what we could do with the next one. The next one will be, see if I can get rid of these marks here. Should be able to. All right, here we go. Next one will be 31 pi radians. I really didn't mean this. 31 pi radians, but let's take a look at it. 31 pi. That would be that. And you already know that in terms of radians, it takes 2 times to go around once. So if I see how many 2 pi's I can get into this, this would be divided by 2 pi. So, of course, the pi's will cancel each other out. 2 will go into 30, 15 times. So we have 15 times around, and then 1 extra pi. So 15 times around would bring us back here, and then 1 extra pi would bring us to this position here. So right here we don't have a reference angle. It's right on the x-axis here. So this one is 60, I said before, and this one is no reference. Right here. 540. I just really made these numbers up, so I made a mistake on this one as well. But 540 would be 360, and then 180. That would give us the 540. You can check with me. 360 plus 180, or you could just say 540 take away 180, and you see what you've got. Rather, I should say 540 take away 360, and you see what you have. Okay, it would be exactly 0. Borrow 1 from the 5. 14 take away 6 is 8, and 4 take away 3 is 1. So it's 180. Lands right here again, right on the x-axis. Nothing in reference to the x-axis. So no reference here. No reference. How about 19 pi over 6? 19 pi over 6. Here's where we divide by 6 and get 6 going into 19. 6 times 3 is 18. So we have 3, 18, and then 1 left over. That would be 1/6. pi. So let's go ahead and see what we've got here. It's going to be 3 and 1, 6 pi. So we would go around, that would be 2 pi. 3 pi would bring up, let me maybe use another color because I'm not sure how to erase this without losing everything. So here we go. If I go in green, that would be 2 pi, 3 pi, and then 1/6 is just the same as pi over 3, pi over 6 rather, and that's pi is 180, so 180 divided by 6 is 30. So 1/6 means we're going to go another approximately 30 degrees, getting us into the third quadrant here. Here comes the reference right here, and you know the reference is just what it makes with the x-axis. So this right here would be 1/6 pi. So that's what this reference would be, 1/6 pi. So that's so much for reference angles. Again, always, always, always in reference to the x-axis. Now, evaluate the specified trigonometric, spelling mistake here, trigonometric function, cosine 60. I trust by now some of you know what the sine of 30 is. This is exactly the same as the sine of 30. So this would be equal to the sine of 30. Why would that be so again? These are co-functions. Remember, the sine of 30 is the same as the cosine of 60, and that is a half. How about number 6? Sine 5 pi over 6. 5 pi over 6. Well, when you see over 6, just like we saw here, pi over 6 is 30 degrees. 5 pi over 6 has to do with 30 degrees. Okay? So let's take a look at what that would be. Pi over 6. Let me see if I can maybe use another color. Pi over 6, what would that, where does that land us? It's going to land us in the second quadrant, because bear this in mind, 6 pi over 6 would be the same as pi, right? And you know where pi is. So therefore 5 pi over 6, a little bit less, would land us approximately here. It has to do with pi over 6, so it's going to be, has to do with 30 degrees. So roughly about here on the reference, where this is 30 degrees. So if you consider this position here on the unit circle, you'll know that since it's pi over 6, you know sine pi over 6 is a half, then pi over 6 will have to do with 1/2 as well. The y coordinate here is going to be 1/2. Why? Because it's above the x-axis. The x coordinate is going to be either root 3 over 2 or negative root 3 over 2. And since it's over on this side, then x is negative going over this side, so this would be a negative over here, root 3 over 2. And I don't think I need this, but anyway, we're looking for the sine of 5 pi over 6, and the sine I told you was the y coordinate, the y coordinate. So right here would be 1/2. Okay, how about cosecant 330? Cosecant 330 is going to be the same as 1 over the sine of 330. That's what cosecant is. It's always the reciprocal of 1 over sine. So here we have again 330, and that should be ringing a bell. 330 having to do with 30. And if I do 330, let's see where I would land up. I'm going to come with a blue now. 330, here it comes. You know it's going to be close to 360 all the way here, all the way around, except for 30 degrees. So my reference angle would be 30 degrees right here. This position is going to be my 1/2 for sine root 3 over 2, or negative root 3 over 2 for cosine, because that's my 330 position. Again, reference angle of 30, always give me either 1/2 or negative 1/2 for sine. What do you think it should be? It's going downstairs, so this is going to be a negative 1/2. And I don't need the cosine here, but if I did, it would be root 3 over 2 in a positive sense. So the sine of 330 would be the y coordinate. So here it is. It would be 1 over negative 1/2. It should be 1 times negative 2 over 1. So this would be a negative 2. So, in general, whenever you see a sine of 30, 330, 5 pi by 6, anything you divide by 6, 5 pi by 6, 7 pi by 6, that will have to do with either 1/2 or negative 1/2. Number 8, how about the tan of 135? Tan of 135. Well, let's see what we have. 135. Let's take another, let's take a look at another page. Not sure I've got this on here. $135. Here we go. Tan 135. Which quadrant do you think we're in now? This would be, if you take a look, so 90 plus 45 would give us 135. So right here we are in this quadrant. On the unit circle, whenever we have 45, 135, 225, we have a certain x coordinate and y coordinate. It's going to be either square root of 2 over 2 or negative square root of 2 over 2. What do you think it should be? We're going this way for the x coordinate. If we were to do a right triangle, it would be down somewhere like this. So this is going to be a negative root 2 over 2. And the y coordinate being above the x-axis is going to be root 2 over 2. So again, 45, 135, 225, 315, all have to do with root 2 over 2 or negative root 2 over 2. So we want to find the tan. And you know tan is sine over cosine. So we're looking at the sine, which is the y coordinate, over the cosine, which is the x coordinate. So here it comes. Sine is root 2 over 2, and cosine is negative root 2 over 2. And essentially what we have is we have a number divided by its opposite. It's kind of like 7 divided by negative 7, or 5 divided by negative 5. This is going to be a negative 1. Okay? Let's see what else we have. Number 8, I'm calling this 8a and 8b. It's cotangent of pi. So 8b, we're looking at cotangent of pi.